We're talking about solving polynomial equations, and we're looking at using factoring to solve them. And so we look at our function here. So after we factor it, then we want to sketch the graph. It's just a sketch, so the thing that's really going to help us out is finding our zeros. So that's what we're going to do. We're going to factor this to find our zeros. And first thing, we should rewrite this so that all of our exponents are in descending degree order. So x to the fifth minus 14 x cubed plus 24x. And then from there, we see that we have a 2x in all of those. So we're going to say we're going to factor 2x out. That's going to leave us with x to the fourth and minus 7x squared and plus 12. Here we have it in the quadratic form, so we can factor that. And we have 2x. And the only way that we can get x to the fourth is if we have x squared and x squared. And we want two numbers that are going to multiply to positive 12 and add to negative 7. So that is going to be 3 and 4. And in order to add to negative 7, they both have to be minus. And if they're both negative, we multiply them together, we get a positive 12. At this point, we might be thinking difference of squares, but this isn't a difference of squares because we don't have a perfect square of 3. So we can do difference of squares for the second binomial. And we can write down 2x times x squared minus 3. The square root of x squared is x. And the square root of 4 is 2. And then that has to be a conjugate pair, so we have to do plus and minus. So we know that our degree is 5, and so we should be looking for 5 zeros. So we have 1, 2, 3, and then we can calculate 2 zeros from this binomial here because we have the x squared term. So whenever we have the x by itself with just a coefficient and no addition or subtraction, we know that the x is going to be 0. So 2 times 0 is 0. That makes the whole polynomial 0. And then here, we take the opposite sign. So negative 2 would make this 0, and positive 2 will make that 0. So those are going to be some of our intersection points. So we know that we're going to have an intersection at negative 2. We know that we're going to have an intersection at 2. And we know that we're going to have an intersection at 0. So we're still trying to find those other 2. And so here we're going to take this binomial and we're going to set it equal to 0. So we have x squared minus 3 equals 0. Add 3 to both sides. And we get x squared is equal to 3. And we take the square root. And we get, anytime we take the square root during solving, we have to do plus or minus the square root of 3. And our radical cancels our square. And so we're left with this, which actually gives us 2 more zeros. We get x is equal to negative square root of 3 and x is equal to square root of 3. And those zeros will pop up just a little bit inside of the 2. And so now when we go to sketch our graph, we have to make sure that we're paying attention to what the graph will look like. So we have an positive leading coefficient and we have an odd function. So we know that it's positive, so we're going to have a slope that looks like something like this. And we know because it's odd that the end behavior is going to go in 2 different directions. So for this one, we're going to start low, and we're just sketching it, so we don't care about the maximums or minimums. And then we're going to find some point, and we're going to come back down and cross back through at negative square root of 3. Then we're going to come back through at 0. And then we're going to come back at positive square root of 3. And then we'll cross back at 2. And then we have our end behavior in both directions going that way. For a little bit better view of what the graph will look like, we have our graph our equation over here on the left. And here we have 0 at -2. That's the negative square root of 3. That's 0, 0. That's positive square root of 3. And that last one is